Here's an interesting example, and I'll show two different ways of doing this. The first one will be an easy way, the second one will be a hard way. So let's see, we have log base 2 of x minus 1 minus log base 2 of x plus 3 equals log base 2 of 1 over x. So the first thing we need to do, no matter what here, is we use the properties of logarithms. A minus outside of the logarithm means we combine with division inside the logarithm. So here we have log base 2 now of x minus 1 over x plus 3. You always combine as much as possible into a single logarithm. Okay, and then we'll just leave the right side alone here, log base 2 of 1 over x. Okay, well, there's a nice property that says log base b of a, if this happens, so let's say if log base b of a equals log base b of, let's make this capital B, then what happens? Well, then a equals b. You can think of it as the logs just go away. Now, that's a terrible abuse of notation right there. The logs don't cancel out, so I'm just going to undo that just because I can't even stand to see it. But mentally, you can think of these logs as almost like they cancel out, and you just focus on the a equals the b. Okay, so in this example, this would be our big A, this would be our big B. All right, so that only works when you have the same log base on each side and nothing else, right? Log equals log. Perfect, that's what we want to have happen. So then we have x minus 1 over x plus 3 equals 1 over x. The question is, can you solve this now? Right, I see a lot of people who get to this point and then they forget their algebra and can't quite solve it from here. So can we solve this? Let's see. What I would do, cross multiply. Boom. Multiply up like that. That happens when you have just one rational function equals another without any pluses or minuses going on here. Okay, so that gives us x times the quantity x minus 1 equals, okay, x plus 3 times 1 is just x plus 3. Okay, remember, anytime you have an x squared on one side, you want 0 on the other side of the equals, right? So what we're looking at here is x squared plus a bunch of stuff, and we're going to get 0 on the other side, right? That's a good way to get yourself out of these predicaments where you have a lot of stuff going on and you forget what to do. Well, where's the x squared, you might ask? Well, it's right here. If I distribute this x through, I get my x squared minus x equals x plus 3, and now I remember, oh right, when I see the x squared along with an equals, that means I want 0 on the other side. So x squared, so I'm going to subtract off this x plus 3, minus 2x minus 3 equals 0. Now, from here, we can either factor it or use the quadratic formula. Luckily, this one factors. Okay, so we have x and x. Let's see, how about minus 3 plus 1? I'm just kind of doing a mental reverse FOIL there. Call that the trial and error method. There's other ways to factor that. And then we set each one of these terms equal to 0 to get x equals 3, x equals minus 1. Now remember, you can't have a negative inside the log, right? So log base b of negative can't exist. Okay, because log only has positive numbers for its domain, right? So we could think of this a few ways, but let's just say for now the domain of log base any b is 0 up to infinity. So that's a long way of saying you can't get answers that give you a negative inside the log. Well, look right here. If I plug this negative 1 in, even right here, I would get 1 divided by negative 1. That would give us log base b of negative 1, which we cannot have. So this solution is out. We call that extraneous, leaving us with a single solution. Notice that the 3 does not make anything negative anywhere. You don't have to check it beyond that. You're only checking to make sure it doesn't give you a negative inside the log. Voila, there is our answer. That's the easy way to do it. Now let's look at a slightly different way. Here we are, same problem. And now let's rearrange it so we get a 0 on the right side, right? some people may have the intuition to do that. So I'm just keeping the first two terms as they are. Okay, now I'm going to subtract off this last term. Log base 2 of 1 over x equals 0. Okay, well, that's strange, but it's reasonable, right? It's not the end of the world here. Let's see. I'm going to use the properties of logarithms again. Anything with a positive in front goes in the numerator inside the single logarithm. Anything with a negative in front goes down to the denominator. So this is a positive term, these two are negatives. What do I mean by that? Let's see here. Combine it into a single term, x minus 1 over, and now we have down in the denominator, x plus 3 times 1 over x equals 0. Okay, well that's serious business right there. One thing we can do is multiply by the reciprocal to get this x up to the top here. Right, this 1 over x in here. We can just bring that x up to the numerator, so we have log base 2 of now x times the quantity x minus 1. Right, it gets multiplied to this whole term up here, all over x plus 3 equals 0. Okay, let's go over here with it. Where can we go with this? Look at this. Log base 2 of x squared minus x over x plus 3. Okay, equals 0. I just distributed this x through to both terms. Okay, now once we get a logarithmic equation like this, where we have a log on one side but a constant of some kind on the other side, we convert to exponential form. So we take the base, right, around about to the exponent, and back inside for the equals. Okay, so this is my power symbol, and then back inside for the equals. Okay, so 2 to the power of 0 equals x squared minus x over x plus 3. Wonderful. Well, 2 to the 0 is simply 1, so we have 1 equals x squared minus x over x plus 3. Let's multiply up by this x plus 3. Okay, so then we have x plus 3 equals x squared minus x. Again, we see the x squared. Right now we're kind of in the clear. We see the x squared on one side, so we know we want 0 on the other. So I'm going to subtract off x plus 3. So I'm subtracting x, subtracting 3. That gives us x squared minus 2x minus 3 equals 0. And back where we were before. Factor, and so on. Minus 3 plus 1 equals 0. And x equals 3. X equals minus 1. But we ditch that one, leaving us with x equals 3 again. Two very different ways to solve the same exercise. Both give the same answer. Pick whichever one you prefer.